So these are my after dinner perambulations, perusing previous presentations of polar predictions. So the polar prediction project has nothing. Okay, so again, I'm going to be really quick. I'm going to try to organize the summary kind of by breakout sessions, again, to try to tee up the discussions later. I'm coming at this from more of the modeler perspective, so you'll see some of that bias probably and some of my own opinions kind of mixed in. But I guess the overall impression from all of yesterday is there's an awful lot going on. So in terms of the first breakout session, we saw some nice reviews of the sea ice outlook in the morning with the comment that they're either really good or really bad. The influence of weather on that and this interesting shift by a year. And my takeaway from that is that we need to time travel things so we can go to next year's predictions and bring it back to this year. So Jim also made the comment that he'd like to keep the research focus, have some near real-time data distribution, and definitely keep the postseason analysis. There's certainly issues of continuing to add uncertainty, and we may wish to add additional metrics, so that's going to be also part of the metrics breakout in terms of what we try to forecast. We kind of need to define this relationship between the sea ice outlook and maybe some of the other experiments we're going to be doing under the SIPN project and what other people are doing in terms of model sensitivities, intercomparisons, that sort of thing. And then issues of how we distribute the information and the data, and that will come out in the data and stakeholder breakouts as well. So in terms of the model experiments and intercomparison, we saw a lot of presentations yesterday again. There were nice summaries in the afternoon by Ed in the early career 4, so that's a good name for a band if you guys want together. Okay. So there are a variety of different experiments we could do. You know, hide-and-casts are very useful for sensitivity experiments. The difficulty of putting together sensitivity experiments was kind of illustrated by the workshop challenge here. How do we initialize these models and how do we create those sensitivity experiments? We can focus on specific issues, things like predictability, the relative roles of dynamics, thermodynamics, you saw some of that, the roles of forcing. But we definitely need to do a lot more of these sort of sensitivity and formal experiments here. There are a variety of configurations, you know, forced single component, partially coupled, fully coupled, to get all the feedbacks. We need to do a variety of those. There are issues with initial state, whether we want to do a simulation or look at the dependence on start dates. Those sorts of comments came up yesterday. We certainly need to evaluate the uncertainty of the models, and some of that is structural uncertainty, things that aren't in the models that we need to represent better. And we need to understand the model biases as well. We should probably discuss today how we want to use these ensembles of opportunity, things like the NMME that are going on, that we might be able to take advantage of. And then I think we have to be careful. We don't want to give ourselves like an IPCC level workload in terms of all the additional experiments we want to do. So we should discuss today how we want to distribute that amongst all the different groups. The other breakout on metrics, a lot of comments yesterday how we get beyond kind of the extent volume. In some sense, we're teaching to the test. So we're doing simulations focused on extent sometimes, and that's not adequate. So we need to move beyond that. Some people talked about going beyond state for mass and energy balance, but then questions come up on data availability if you want to validate those. So that gets into the data breakout as well. Moving beyond kind of basin-wide scalar metrics and starting to look at spatial patterns is going to be important. Trying to develop a skill score as the operational folks do, and taking advantage of testbed tools that might be out there. On the data breakout, so there are certainly a lot of questions about what format we want to do. Obviously, modelers want the gridded data for model validation, but that's not true for other stakeholders and the general public. So different formats for different stakeholders are going to be important. There were questions brought up yesterday about which standards are important and ease of use, particularly as we get beyond our own community and into other folks that need to use the data. A variety of data products are also needed. There's sort of the raw, uncooked data. There's the idea that we have to integrate some of these data sets together to create more polished products. And at least for the public, some of those products are in the form of just figures and animations that can go out to the public for understanding. But there's also this difference between data for ingestion, if we want to assimilate data and validate models, and then the actual final results that we want to distribute to other stakeholders and users. Uncertainty comes up again. Distribution methods, we need to take advantage of distribution methods that are out there or come up with efficient ways of doing that, particularly as we get into more rapid distribution of some of that data. And then there was the comment yesterday about models can provide input on which new data can be most useful. And then finally, outreach. This is an area that's not my area of expertise, but certainly we saw presentations yesterday on the surveys and opinion polls. We need to be able to translate those, the results of those surveys into the kind of needs and metrics we want to define. And at least my experience from some previous surveys that not in this community, but in other communities, is that you tend to get responses from folks that say, just, we want everything. And other folks is that they don't even know what's available and possible. So particularly for that latter, that involves more of a dialogue. We heard from our blogging friends that lots of plots are useful in terms of informing the public. And then for the stakeholders, we need, again, to go beyond CI's extent. For some stakeholders, we heard yesterday, thickness is important, and dates and time-related metrics are important. And then we'll need to develop others based on those surveys again. So that was my summary, I guess.
Okay, I'm going old school with my scribbled notes on hotel stationery. And I knew Phil was going to do a great job, and that I probably couldn't hope to match him. So I thought I'd take a little bit different tact, and rather than recap what was said yesterday, which again I think Phil recapped really well, I thought I'd try to recap what wasn't said yesterday. And I think that might be fruitful for thinking about the breakout groups today. And the one thing that was quite notable, I thought, was the lack of talking about statistical methods. And I want to make it clear that this was not the fault of the committee and the organizing committee. I'm not just saying that to be self-serving as a member of the organizing committee, but I think there just wasn't as much participation. But I think it's important to consider that, particularly from what we heard from some of the modeling talks and the challenges with that. We certainly should not ignore the statistical aspects. And we'll address that in a few minutes with Drew Slater, that will talk about his approach, which is quite interesting and has shown some promising results. Another thing that we didn't talk about too much, we talked a lot about skill and metrics, but we didn't really talk about, well, what skill is needed? And that's something to keep in mind. What would be a useful forecast? Certainly you want to measure the skill accurately, but you want to see, is it going to be useful? I've seen, some of the Outlook submissions, and there was some of the plots that said, well, the ice, is going to be X million square kilometers plus or minus a million. And it's like, well, I could do that right today, off the top of my head. And that's probably not really useful. But do we need to get within 100,000? Do we need to get within 250,000? And in terms of regional, do we need, where do we need to know where the ice is going to be and so forth? Talked a lot about the observational needs, but it was focused mostly, I think, on the current data that's out there and what, what formats are needed and what kind of accuracy. There's a lot of talk of concentration, thickness, and better thickness fields, but I think we should also think a little bit outside the box of what observations that aren't being currently collected or distributed that could be useful. One thing that stuck out to me was melt ponds. That was mentioned yesterday. There's not real good melt pond data or any kind of parameterized observations of melt ponds even. But there's probably others. Also, forcings and reanalyses. What kind of skill do those have, and how do those affect the models in terms of we use those kind of as inputs to force the models, but of course there's uncertainties in those, and what kind of biases might affect that. So that was the things that came to my mind, and I thought if we can spend a few minutes, that I know I haven't captured everything, and if anyone else has anything that they noticed or comes to mind that they think should be addressed today, I think that would be useful. So I'll open up to that before Drew comes on. Anything? No?
So just to remind you that we'll talk about operations center and data assimilation. Those are covered, right?
Yeah, and I note that in the breakout groups and stuff, there are some more things to come, but because we didn't explicitly cover those, I'm gonna make sure that we keep these in mind for today. So, okay, Drew. Oh, Jim, did you have?
Maybe thinking a little bit more on what's the balance between using models to go forward on the outlook forecast level and tuning and the predictability studies. I think we want to make sure here that they don't wander off in separate paths.
Mm-hmm. Yeah, I think that's a good point. We definitely want to try to keep coordinating and make sure that, that's part of the idea of this project, is to kind of herd the cats and keep things focused and moving forward together so that we can really make some good progress. Yeah.
One of the things that we haven't talked about, but which is really important to shipping and stakeholders and anyone who's not really just pure science, is fast ice. Any shipping route is going to be affected by fast ice, and there's really no good model for fast ice yeah.
Okay. Yeah, that's a very good point. And there's not a whole lot of data on fast ice either. You can derive it, but it hasn't really been a focus, so that's something to keep in mind. Yeah.
Yeah, I guess one point on that is even with AMAP that's looking forward to their adaptation, they're picking three regions: the Greater Chukchi, the Bering Sea, and Baffin Bay. So they're already moving off from this art-wide view, single number, to the regions, and so there's a question of the regional modeling. Do we just take the art-wide models and up the resolution, or do we nest an Alaska-centric model, or change the scaling as Jin Lin is done? I didn't hear, other than what he mentioned, I didn't hear much discussion of how we went from the art-wide predictability scale to what an oil company or a shipping company might want, and what we might be able to do in 10 years.
Yeah, I think that plays into what kind of skill is needed and what the stakeholders needs. A lot of the stakeholders' needs are very regional, and I think as this evolves, I think there's going to be more and more interest in probably more focus on regional, and how to get there is an important thing to talk about. Yeah.
If you're looking art-wide, when will the summer ice goes away, we can argue 5 years or 30 years, but if you live in Alaska, the future's already here with an ice-free summer,
Yeah.
except for last summer.
I thought your point about reanalyses was a good one, but it's not clear to me what you were thinking. Were you thinking of an intercomparison of all the reanalysis products, and maybe even against in situ observations where they're available? And maybe not just sea ice, but surface temperature over the Arctic. I don't think that's being done.
I was thinking very, very generally and very high scale, and I think specifics would be needed in that. But just kind of the sense of people, as I see it, and I'm not a modeler, but like, okay, we have this model, and then we forced it, and we looked at the model physics, and we looked at compared to the observations. But people I don't hear a lot of like, well, what did the reanalysis? I hear about biases in the reanalysis, but what kind of effects they might have on the models, and I think that's an important consideration as we move forward, because one of the things. Even if you have an absolutely perfect sea ice model, if your reanalysis are an error, you're still not going to get a very accurate forecast. So, yeah.
Just to mention a point about this reanalysis issue, what I mentioned yesterday, this project of intercomparison it's not just only on the sea ice cover, it's also on all the ocean part, and there will be this special issue on climate dynamics in July that will pass through all the ocean variables like ocean upper heat content or sea level rise or things like that. So just it's work ongoing for the ocean part at least.
Just to go back to the regional scale, NRL right now has a research project that's developing a coupled ice-ocean atmosphere model at the regional scale, and we're looking at our first opportunity of our first area of interest is in the Beaufort-Chukchi Sea area, and we're looking at 1 kilometer resolution. So just for FYI.
Again, a comment on reanalysis products. In our first model, we have the problem that we have too less ice in summer on the Eurasian part of the Arctic and too much ice in the buffer sea. And I played around with all the parameters we have, drag coefficient and so on. And my feeling is now that we really have a problem with the winds in the Arctic. And what we did is we used almost all, no, not all, but 5 or 6 available reanalyses and compared them. And the good news is that the newer products like NSAP, CFSR, and error interim are much more closer to each other than the older one. But we are still empty-handed because we have no data, for instance, in the Canadian Arctic. We have a few data in the Eurasian part and in Svalbard. We had a meeting on Access last month, and there Harald Schuberg showed up a project, a comparison of reanalysis product, the Norwegian product and error interim, and the skill. And there's a clear skill gradient from south to north. So even in Svalbard, the analysis is in temperature and LZP much worse than in the south.
One more, and then maybe we'll move on.
Yeah, I just wanted to add to Matt's comment on the ocean reanalysis project. I mean, most of that has been I can't remember the word I want. Has been focused on the global. So the data producing centers would probably be ecstatic if anybody went and asked them for the data so they could look at regional studies. So Arctic studies are even smaller regions than that. Not that global oceans are great for regional analysis, but the data producers would be probably ecstatic to get requests for data.
So some people might be wondering what I'm doing here, because most of my Arctic work is terrestrial based. I work a lot with the land group here. Permafrost and snow is really my zone. But there's a couple of motivating factors for having looked at sea ice. And last year I was invited to go on the Nabos cruise, which went from the Barents Sea across the Kara, Laptev, out to the Siberian Sea in August and September. And if you remember 2012, there was no ice there, so I was a little worried that I wouldn't realize my dream of seeing a polar bear. There wasn't a sort of mid-range forecast of sea ice for the period that I was interested in. I asked a bunch of people, and no, we don't really have one of that length. So I decided to make one, and then I decided to sort of follow it up. The other motivating factor was kind of fun to taunt Julianne and Andy with my, ooh, look at my pretty pictures. So I've worked with the Weather Service before in terms of hydrologic forecasting and land model forecasting, so I have a bit of a background in forecasting. But I decided to try and do something with sea ice, and at NSIDC it's impossible to avoid sea ice. And so I made this very simple forecast. It's a 50-day lead time, which I sort of chose arbitrarily because I just wanted to see 50 days out. It only uses sea ice concentration, which is easily available from NSIDC. And I forecast for every single point independently in space and time. So no single point knows what its neighbor is doing, and it doesn't care what it or its neighbor was doing for yesterday. It's based on assessing the probability of ice existence 50 days, at the lead time out from when I'm looking. And this is a plot from, let me see, it was a plot for 19th of September, and I made it on the 31st of July. And so this is the probability of ice occurrence at any given point, and that was the verification plot. And then in order to get an area, an extent, I integrate the probabilities, and we can see up here that in this case, of course, I'm going to show you a good result, 4.93, 4.94. So it looks pretty good and wonderful. It's useful, it's not all that. And I'm just going to run through some quick results here, just to say that I do it on a daily time step, so I forecast every single day, and these are the results. This is 50-day lead time for all the different years. I submitted it to the Surge Sea Ice Outlook for the August result, and here I was, number 2 behind Antoine Barthélemy from the Belgian group. Antoine was actually on the cruise with me, and it was kind of fun. It's like, ooh, let's see if we can drive the ship through some more ice and break up some of this ice. I do a little better than Antoine, but it's and a couple of interesting features to point out. I really liked this result in 2009. So I was doing very well, and then 50 days out, the system predicts that there's going to be a change and then a change in gradient. That I thought was pretty cool, actually. Obviously, it overcooked it and went a little far. And then you have years like 96 where it gets the rate of change right, but obviously underdone. 2007, again, rate of change good, but a little overdone. And just, I looked at September mean because that's sort of the thing. The thing I'm actually looking at is the NASA team observed extent, because that's the data I have. And that's what I sort of verify against. And then Larry's results, no one got 2009, so I was actually pretty stoked. I was like, yeah, 2009, got it. And from the Sea Ice Outlook, for the period of the Sea Ice Outlook, I got 9, 10, and 11, better than most other years. This would have been quite a spectacular result. But the thing is let's not get too carried away. The RMSE is good and that sort of thing, but I actually think where this sort of system can be most useful is in terms of diagnostics of the coupled models maybe, and see where do they produce this sort of result. If I use concentration from the coupled models, can I reproduce this sort of result? Why in 1996 did I miss when I got the gradients well? Why did I get this result? the system is still somewhat arbitrary. There's lots of random constants that I just put in there and made decisions myself. But it's a case of, for an intermediate situation, I think statistical forecasting has quite a bit of value. Someone said something about fast ice. Well, you can sort of, there's little bits of fast ice here and there. It's not perfect, but it gets a few of those items and it's probabilistic. And that's really all I wanted to say, is that there are other options out there. I think coupled modelling is really where it has to go in the future, process-based coupled modelling. But in the meantime, some of these items can be used in terms of assessing how the other models do, and they have some value in their own right. So I think I'm just going to leave it at that to get us back on track.
Can you just expand a bit more on the methodology of how you're making this forecast?
It's magic. See, this is why I enjoyed. Yeah, so it's very simple. For the melt season, most of the skill comes from survival rate. So take a point for a given day, for a given ice concentration, and see what its probability of survival is 50 days out. And you develop these curves for each day of the year. I take all prior data from the last 9 years, and I say, if a point had, let's say, 80% concentration, okay, let's do it. Let's say 80% concentration, and it's June 9th. If a point had 80% concentration, its probability of survival is somewhere around 60%. Very simple, really ridiculously simple. And then I take, at the issue date, I say, well, what are the concentrations? This point says it's 80% concentration, so I assign it a 60% probability of survival out to the next 50 days. So it's very, very simple. I update these curves. For each year I use the prior 9 years of data, and you can see that as the ice has thinned, so this is just one curve for July 27th, you can see that the probabilities have dropped for a given concentration as the ice has thinned. So again, 9 years is just me going, 9, that'll work. And then
Is it sensitive to the number of years you look back?
I don't know. I think it is a little, I mean, if I go all the way back, then yes, because what you're trying to do is you're trying to capture how the main ice pack has changed. So if I used all the years, then my average curve would be somewhere in here, and therefore I wouldn't get as good a result. So it is, as the ice pack is thinned, you want to sort of pull this curve back this way. So.
Didn't plan this, so we're going to have to.
Yeah, sorry.
Sorry,
thank you.
Yeah, actually, we invited everyone who contributed Sea Ice Outlooks to come to this workshop, and not very many statisticians responded. Well, I think actually that's a good point, because there are a lot of statisticians who contribute, but I think they don't think of themselves as sea ice people. And so maybe they didn't respond to our call because they thought this would be more sea ice than they were really prepared to look into. So I'm trying to decide which is the best way to do this. To set us up on the breakout group activity, which starts now, we have 4 breakout groups. We had initially talked of having 5, but based on your responses on the fill-out form yesterday morning, one of them was not very highly populated, and so we combined it. And that was the one on stakeholders, actually. So we combined it with number 1, which is the Sea Ice Outlook recommendations. So we thought those two could work together fairly well. And so the number 1 has a fairly broad task now to talk about the next generation Sea Ice Outlook, address stakeholder needs, and improve communication. But they're pretty related. And then the second is about the design of intercomparison experiments, so MIPS. Obviously, there's some overlap between those two, but I hope you can try to work separately, and then we'll talk about it all together in a 45-minute period at the end of the breakout sessions. 3 is the design of metrics to validate predictions, and 4 is observational needs. Obviously, there's some overlap between those two as well. Now, we'll have 2 sessions, one before and one after the break. And before the break, we have about 45 minutes. And so it'll be the shorter of the 2. And after the break, we have about an hour. Although you can, of course, shorten your break voluntarily if you'd like. So the break is planned to be at 10:15. But during these breakout sessions, what I'd like you to do is to focus on producing 5 key recommendations for currently achievable objectives. That means what we can do with our current resources, our current projects. And then we want you to not limit yourself, but think of a few bigger ideas, grander ideas that might be achievable in the future with further resources, further workshops like this. Does that make sense? So would you mind passing around those? There's 4 copies of the list that I'm also going to post right now, and we'll leave up in this room. Here's the list. And can you read that? Probably not. Maybe I could actually make it a little bigger. Oh, that didn't work. I want both pages. Okay. So the same thing is being passed around. And as I said, there are 4 breakout groups and 2 sessions. So A is before the break, and B is after the break. And there are going to be 3 locations, unfortunately. We don't have a 4th room. So we'll put the 2 smaller groups in this room, so you just split the room in half. And the 2 smaller groups are this and this. So the next generation sea ice outlook and observing needs will be in here together. And then there's 2 small but manageable rooms that are the director's conference room and the Chapman room. They'll each hold about 20. They'll be tight, but that's how many we have approximately to move into those rooms. So the directors, they're both on the 2nd level. I think I know where they are. The directors, you go up the stairs and go left, and just at the double doors that take you into the office area, don't go through, but look to your left and you'll see the director's room. And then the Chapman room is go right and look for the restrooms, the men's room. I think it's just next to the men's room. Did all right? Okay. Does that make sense to everyone, where they're going? And then the stars are indicating mostly sea ice project team members, SIPN team members, who are going to corral and run the session, but you don't have to do everything. I want the person who's noted with the star to ask for a note taker and also ask for someone who will come back and report. So hopefully it won't be the sea ice project team person reporting, because you've heard so much from us already. We want to hear more from you. Though hopefully you'll get volunteers, but the stars, the person who's going to be trying to organize. Okay, does that make sense? And all of the stars are next to sea ice SIPN team members, except for Andrew Roberts, who we've deputized. Thanks. Is that clear? So after the break, we'll have an hour, so until 11:45, and then we'll come back in here for 45 minutes, and we'll report. And I think just speaking is fine. You don't have to have a presentation. So we'll have 2 sets for each, right? And it'll be interesting to see if there's some overlap. Okay? All right. Any questions? Great. Thanks.